Hi everyone, welcome to this TTK tutorial. Here we will learn how to install, configure and use TTK with Catalyst. In particular, we will use it with a computational free dynamic simulation code called Code Saturn. So for that, we will use two different systems, a client system and a server system. We are currently running the client system, and we are connected to the server system through SSH in this terminal. Let's begin. In the first step of this tutorial, we will download Mesa, ParaView, and TTK. So for that, we'll enter the command wget.o Mesa and the version 17.2.0, and we will copy the download link here. Enter. Okay, now we will download ParaView. wget.o ParaView and the version 5.4.0 and the download link here. Okay, finally we will download the TTK package wget.o TTK and the version 0.9.2 and the download link. Okay. In the next step, we need to install these dependencies on the system. So I will copy this command and enter it on the server. This command requires root privileges. Okay. Why? So now we will prepare the sources. So first, we will create our working directory called TTK. And we'll move our tables in this directory. So into TTK. Move ParaView into the TTK directory. Move TTK source code into the TTK directory. Okay, we'll move into this directory and we will decompress all the packages. So tar xvzf Mesa, like that. Tar xvzf ParaView. Enter. Tar xvzf TTK. Okay, so now we no longer need the tables, so we will delete them. rm Mesa, rm ParaView, rm TTK. Okay, and in the next step we will patch the ParaView source tree. So for that, we will move into this directory and apply the patch, which requires the path to the ParaView directory. As a parameter Okay, so as we can see, the patch has been successfully applied on the ParaView source tree. So now we can move on to the next step, which is the configuration of the packages. The first one is Mesa. So let's move on to the Mesa directory. TTK Mesa. We will create our build directory and move to this directory. Okay. And then we will configure it with these options. Here, we will disable XVMC. We will disable GLX. We will disable GBM. We will disable TRI. We will disable EGL. With Gallium drivers equal SW Rust. Enable texture float. Enable Gallium OS Mesa and press Enter. Okay, so now we can start the compilation process by entering this command, make.j, and the number of available cores, which is 8 on this machine. Okay, so now we will install our build of Mesa on the system by entering the command sudo make install. Okay, let's move on to the configuration of ParaView. So first, let's move to the ParaView directory and create a build directory and move to this directory. Okay, so here the configuration will be made with ccmake. The configuration interface opens and we press C to configure. Okay, so this is a small warning. We will press E to dismiss. Okay. In this part, we can put these options in order to use ParaView with TTK. So, CMake build type must be released. ParaView enable Python must be on. ParaView install development files must be on. The ParaView Qt version is 4. And we must check that VGK rendering backend is OpenGL2. So that's the case. So additionally, to enable the in-situ usage of our build of ParaView, we will also set these options. So for that, I will enable the advanced mode by pressing T. Okay, so here to make a search in the options, we use and type ParaView. Enable Catalyst. Okay, it's already on. Another search, ParaView, use MPI, must be on. ParaView, build Qt GUI, must be off. VTK use X must be off. Now we will clear the OpenGL directories. OpenGL blank blank. Okay, OpenGL include there OpenGL GL library, OpenGL GLU library, OpenGL XMesa include there. Now we'll search for VTK OpenGL as OS Mesa. Okay, must be on. VTK use off screen. It's already off. So now we'll press C to configure. Okay. So now we will check that the OS Mesa directories are correct. Another search, OS Mesa. Okay, we can check that it is the same. Now we can once again press C to configure. And finally we can press G to generate and exit the interface. Great. Now we'll start the compilation process by entering this command, make.j and the number of available cores, here 8. Okay, so now we will install our build of the ParaView into the system with the following command, sudo make install. This command requires root privileges. Great. Now let's move on to the configuration of the TTK package. So the TTK module. So here first let's move to the directory of our installation of TTK. So cd TTK 092 make we will make our build directory and move into it. Okay. Then here we will use ccmake to configure and press C. Okay, and here we don't have anything to modify, so we'll press C once again to configure, and here we have access to the generation process, so we'll press G. Okay, so now we can start the compilation process by entering the command make.j and the number of available cores. Okay, so now that the compilation is finished, we will install our build of TTK on the system. So for that, we'll use the command sudo make install. Great. So let's move on to the next step, which is the computational fluid dynamics use case with Code Saturn. So here we will see how to use TTK with Catalyst in a typical computational fluid dynamics use case. And we require that Code Saturn is installed in both systems, but here we will explain how to install it on the server system, and as it is the exact same procedure, the Code Saturn is already installed on the client system. So first, we must download Code Saturn on the server. So for that, okay, we will use the command wget.o Code Saturn and the version, so 5.0.4, and we will copy the download link here. So copy here. Now we will download all the required dependencies with this command, which requires root privileges. Yes. Okay. So now we will prepare the sources of Code Saturn. So for that, we will first move the tarball of Code Saturn in the TTK directory. Okay. Then we will move into the TTK directory and decompress the Code Saturn tarball here, and we can delete it because we don't need it anymore. Okay. In the next part, we will configure Code Saturn with the correct options and parameters. So first, we need to move to the Code Saturn directory. Okay. Then we create a build directory and move into it and configure with these following options. So with Catalyst, equal /usr/local/ and disable Catalyst as plugin and press enter. Okay, so now we can move on to the compilation process by entering this command make.j and the number of available cores. Okay, so now we will install our build of the Code Saturn into our system with the command sudo make install. Okay. We are now in the post-installation configuration, and here we will edit the .bashrc in the home directory and add these two lines in it. So for that, we will edit this file with Vim here, but feel free to use any editor you want. Save and exit. Okay, so here to apply these modifications into on the current shell here, we will now use source bash rc. Okay. Now let's switch to a terminal in the client system. Okay. So here, in order to use Code Saturn with Catalyst on the server, we need first to create a representative Code Saturn dataset on the client system. So for that, we will move into the TTK directory, okay, and create the study simple junction with its calculation directory named case1. We can do that by entering this command. Okay. So now we will copy the pre-configured project in the Code Saturn source tree. So for that, we will move on to our project directory. Then we will copy from the examples the one which we are interested in, simple junction. Okay. Then we move back to the mesh directory. Okay. Then we copy the mesh present in the examples directory in it. So cp TTK Code Saturn example 1 simple junction mesh. Okay, here we move back to the root of our calculation directory, simple junction case 1. Okay, great. So now we can run our basic simulation to create our representative dataset. Code Saturn run param case1.xml. Okay. So when this step is finished, we can look at the results in the following directory. So here in TTK, simple junction, case1, resu, date and time, post-processing. We can now check that we have this file, okay, which will represent our entry to the simulation in ParaView. Results and site.case. Okay, so it's in here. So now let's move on to the generation of the Catalyst script. So for that, we will open ParaView. So here, ParaView. Okay, close. So now we need to load the Catalyst script generator into ParaView. So for that, we will look at the Tools wizard here, Manage Plugins, and go to the Catalyst Script Generator plugin here. So load selected. Okay. And here we can see that two new menus have appeared, a coprocessing one and a writer's one. And now we will download our visualization pipeline with the ParaView state here. So we will download our state here, ParaView pipeline. Okay. Then we can go back to ParaView and load our state. Load state under the File menu. Into the Download directory, we have our ParaView pipeline here. We choose file names, and here we must put the directory to our representative dataset. So here it's TTK simple junction case1 resu date and time post-processing results and site.case, and press and click on OK. This will apply our pre-configured visualization pipeline with calls to the TTK features, as you can see. And now we'll start the generation of our script by clicking on the coprocessing menu and export state. We'll click now on next. We will add this source, add, click on next, next again, and we will select output rendering components here. Okay, so here we can configure each view with these options: image type, file name, write frequency, magnification, and fit screen. So here we will rename this output to make a short description, so flat domain. Here we will now go on to the next view. Okay, this one is a warped domain. Okay, the next view here, it's the persistence diagram. We want it also to fit the screen. Okay, next view, and here it is the persistence curve, and we want it to fit the screen also. We click on finish. Okay, and we can select the path which will be used to write the script, and the name of the script, TTK pipeline.py. Okay. Great. We can now close ParaView. Okay. So here we just have done all those steps of the configuration of the script and its exportation. Now let's move on to the next step of this tutorial, which is the patching of the Catalyst script. So first, let's move on to the path we used to write the script. So it was in downloads, and let's edit it with our editor here, Vim, TTK pipeline.py. Alright. And we will add those lines here just under those Python import lines here. Paste. We will write and exit. Okay, so now our Catalyst script is now patched and ready to use all the TTK features. Now we need to integrate this Catalyst script into the CodeSaturn project. So for that, we'll first go to the directory of our case study, located in this directory. So we'll copy this command here. Okay. And we will now open the CodeSaturn project manager here. Enter. Okay. So now we need to add the Catalyst writer into the project. So for that, we will click on the calculation control drop-down menu and output control. Now, on the writer tab, we will click on the plus at the bottom of the application. Okay, we will now double click on the writer, the new writer, and call it on the same name of the Catalyst writer, so the Catalyst script. So it's TTK pipeline. Okay, enter. We will click now on the format. So here it's not in-situ but Catalyst. Okay, and we will change these frequency options too. So it's output every n times, where n here is 1, so each time step, and output at end of calculation. Alright. So now we will now move to the mesh tab and click on the free domain. Okay. So now, normally, with the writer correctly added, here we just click on the plus button at the bottom, and automatically it will add the TTK pipeline writer, so which we just configured before. So now we can save our project and exit the CodeSaturn project manager. Okay. So we just have done all these configuration steps here. Now we can run TTK in-situ on the server system. So let's go back to our server terminal. So here, for simplicity, all of the configuration files which need to be sent to the server are already present on the downloads directory on the server here. So we will now create our mirror project on the server. So we will go into the TTK directory, okay, and create our mirror project with this command. Okay. So now we need to copy TTK pipeline.py and case1.xml in this directory. So mv downloads TTK pipeline into this directory, mv downloads case1.xml into this directory. Alright. And we also need to move the mesh, okay, into this one. Alright. mv downloads downcomer into this directory. Alright. So alternatively, you can also download a pre-configured tarball which will recreate all the configuration, all the pre-configured CodeStation project directly on the server, so that you just have to run it with these two commands. So that now that our mirror project is ready, we can go into this directory. So it is the directory of the calculation project of the simple junction study. Okay. And now we can run our simulation in situ with TTK features. So code satur run param case1.xml. Okay. And this time it will load all of the filters of TTK and run the simulation in situ. So what you see here is the output of TTK at each time step. And the calculation results will be stored into this directory here. You can now see the results as videos generated with FFmpeg. Okay. And that's all for this video. Thank you for your attention.